Good morning. This lecture is on helicopter history, the first 50 years of development. The story is adapted after Ray Prouty's book, Even More About Helicopter Aerodynamics. The name helicopter comes from the Greek heliko, pteron, spiral wing. The most known example of a rotor is the Chinese top, which is a propeller attached to a stick. If one spins the propeller, it will achieve lift and fly. Who should get the credit for the first helicopter flight? The first example is of Breguet multirotor gyroplane, which claimed in 1907 that he was flying the first helicopter. Breguet developed a multirotor helicopter and has placed in each four corners a man for stability of the helicopter. Later, in the same year, Paul Cornu was flying a tandem helicopter. Engineers later have doubted that his machine had enough power to fly. However, Corner say that in front of 60 witnesses he had a model that he was flying. Wright brothers were also making several models but gave up for developing further the kite and the glider. They said that the helicopter does with great labor only what does the balloon without labor. The first successful flight of helicopter was actually from the father of helicopter, Sikorsky. Sikorsky tried to fly a rotary wing aircraft in 1909, the Sikorsky S-1 coaxial. He tested his second machines and showed that could achieve almost lift its weight, but no more. The honor of the first documented helicopter flight goes to Jens Ellehammer in Denmark. Ellehammer demonstrated his helicopter in 1913 in Copenhagen in front of His Royal Highness Prince Axel. The Prince issued an official statement which was saying that indeed this strange-looking aircraft was rising by its own power. In 1908, the era of gyroplane started. The gyroplane is an aircraft which is supported in flight by unpowered horizontal rotor wings, and it has achieving forward propulsion by a conventional propeller. Here you see the well-known Breguet gyroplane in 1908. By the early 1920s, there were about 6 machines that could make a few feet above the ground and go approximately in the direction the pilot desired. The first lucky breakthrough came from Sierva. Sierva developed the autogyro. Sierva discovered the principle of autorotation by looking at the windmills. He had an aircraft accident in low-speed stall. Then he thought that instead of depending on the forward speed of the whole aircraft for generating lift, what if the wing was rotated so that it had speed with respect to the air? And so the autogyro was found. Here you see the Sierva in front of his first autogyro. The autogyro had a problem in forward flight. As you are flying in forward flight, one blade is advancing and one blade is retreating. So there is a difference in the relative air velocity attacking the advancing blade and the retreating blade. there is a difference in the lifting forces, so the helicopter will roll. Sierva was trying to solve this problem of the autogyro, and he was finding that his model scale autogyro were flying, however, the full scale autogyro were not flying. He understood that actually the difference between the model autogyro and the full-scale autogyro is that in a model the rotor blades were made from flexible spars, while in a full-scale autogyro the blades were rigidly attached by wires. In this way, Sierva developed the flapping hinge. He understood that installing a flapping hinge will allow the blade to flap up and down and will eliminate the asymmetry problem in forward flight. Another merit of Sierva is that he invented the cyclic pitch control on the helicopter, and thus the autogyro pitch and roll. The early autogyro, it was nosing up flapping of the rotor, which resulted in a nose-up pitch moment balanced by an airplane elevator. The pilot had ailerons and rudder for roll and yaw. However, these were not effective at low speeds. The 1930s is known as the era of the autogyro. Here are some famous autogyro. The Harold Pitcairn. Before the World War II, it was easy to fly, it was simpler for the fixed-wing pilot to transition to, could do almost everything what a helicopter could do, except of course hovering. Another autogyro was the Anton Flettner Colibri. It was a very famous autogyro in the World War II, and Germans used captive autogyro kites towed by surfaced submarines to extend their horizon. 24 of Colibris were built in Munich before the factory was destroyed by Allied bombers. Fokker Drake Autogyro went into production of 400 autogyros per month in the World War II. Only 39 have been built before the Russians overran his underground factory. Another famous autogyro in the United States were built by Kellett, one of the most successful autogyro in the pre-war time. By 1928, the helicopters were still struggling to stay aloft for more than 10 minutes. Sierva Autogyro was flying from London to Paris at more than 100 knots. Hovering was what the military wanted and they were prepared to pay for. The first successful helicopter was the Sikorsky R-5. During the World War II, military helicopters were developed and production lines were established in Germany and US. Sikorsky started in 1943 to deliver more than 400 helicopters to the Allied forces. Mass production has been stopped at the end of the war. By 1945, the square-cubed law applied to the helicopters with mechanical transmission proved that helicopter with a gross weight of about 2,300 kilograms was the maximum. However, today we are flying Mi-26, which has a gross weight of 56,000 kilos. How was this possible? At the end of the World War II, the small Sikorsky helicopter was a successful machine to transport soldiers, but the maximum that the army could get to transport was a jeep because of the weight which was necessary for transmission. So transmission needed to be eliminated. The solution came in the form of the ramjet helicopter. The McDonnell Little Harry, developed in 1947, applied the jet propulsion of the helicopter at the end of the tip of the blades. So, imagining that the rotor blades are traveling in high subsonic speed range, here the jet engines are very efficient. Using these engines, one can eliminate the heavy and complex transmission and get rid of the tail rotor. The Colibri in 1956, it went into production in Europe. At Sud Aviation, Dijon in 1953 went also into production. The disadvantages of the tip jet helicopters are that are very pure, they have a very pure fuel efficiency and are very noisy. The advantages is that they do not need a tail rotor and they do not need transmission. The flying crane was a helicopter prototyped, built in 1952, and it had a payload of 9,000 kilo and a range of 50 miles. This was, in Europe, the Fairey Rotordyne, which was a compound autogyro invented by John Bennett for commercial and military applications. It had jet-tip powered rotor, burning fuel with compressed air bled from two wingtips mounted turboprops. Rotor were used for the vertical takeoffs and landing, and wings and propellers were used in forward flight. The Rotordyne was cancelled because of the politics and the lack of commercial orders. By 1950s, the developments in tip jet helicopters were not really progressing. The revolution came in the turbopower shaft engine. In 1957, the developments of the jet engines for fixed wing resulted in developments of the turboshaft engine. It was realized that by placing a turbine behind the jet, the power given by the hot gases can be transformed into mechanical power to rotate a propeller. The advantages of the turboshaft helicopters are: they have a specific fuel consumption better than the replacing piston engines. They have a reduced weight with respect of piston engines, 1/3 of this. Helicopters, you have to understand, are much more weight sensitive than airplanes. If the aircraft weight is increased, one can increase the length of the runway. If the helicopter weight is increased, it results into degradation in its performance, less weight able to be carried for a takeoff. By the beginning of the 1960s, the helicopter started to look as we know today. Between Sikorsky S-62 and Agusta EH-101, it has an incredible similar, they look incredible similar. What happened in these next years? This is the end of this part of the lecture 1.